So if we are proving, our first step is to go left side, right side. And then rewrite it. Cotan x minus cosecant x. And then cos 2x minus cos x over sine 2x plus sine x. So the first thing I would do, the right side has to get worked with at some point, but I would try and make my left-hand side possibly look like some sort of fraction over a fraction to help me with the right-hand side, is to figure out what I need to pick for that cos 2x. So what is cotan? Cos x over sine x. And what's cosecant? 1 over, and we already have a common denominator, so we can write it as cos x minus 1 over sine x. Okay, the next one, the sine 2x is only one formula. There's no other options, right? I can't do anything. So I'm going to leave the cos 2x just out for now. I'm going to go minus cos x. And then on the bottom, I'm going to get 2 sine x cos x, which is what cos 2x is, plus sine x. I'm going to, actually, for me, I'm going to leave the cos 2x for now. So I'm going to do something else next. In the bottom, can I do anything to that denominator on the right? Take out a sign. Yeah, in the denominator, take out a sign. Remember when you're stuck, 99% of the time it's a GCF? So I can take out a sine x, and then I'm left with 2 cos x plus 1. Now, when I look over here, I say I need to keep a sine x. See, there's a sine x here and there's a sine x here. So I need the 2 cos x plus 1 to get out of my life. Right? So I have to pick from the formulas over here. I have cos squared x minus sine squared x. I have 2 cos squared x minus 1. I have 1 minus 2 sine squared x. I need to get 2 cos x plus 1 to go away. What could I possibly do here? 2 cos squared x minus 1. That would be what I would guess. I'm going to try it, because it's the only thing that has coses. If I go cos squared x, sine squared x minus cos x, what am I going to do? So that's the best bet, right? So we're going to replace it with 2 cos squared x minus 1. What can I do with that top? If I write it in order, I'm just going to write it over here off to the side in order. You can factor it. So I'm going to factor it off to the side. Hello.
I was wondering if you look at anything you can see yours left.
Sure. We don't need lunch. We have cake. Marie Antoinette says, let them eat cake.
Yeah, you will.
All right. So, let m equal cos x. Thanks, Ryan.
Wow.
Cohen's just like, thank you. Okay, so we get 2m squared minus m minus 1. What can I factor that? What multiplies to give me 2 and adds, or negative 2 and adds to give me negative 1? Yeah, negative 2 and 1. So I get 2m squared minus 2m. Sure. So we get plus 1m minus 1. We group, we take out a 2m, and we're left with m minus 1. Plus 1, m minus 1. And we get 2m plus 1, m minus 1. So much cake being handed out today. It's all those big, the big decorative cakes. All right. So I can replace this up here with 2 cos x plus 1. Something's matching, something's matching, something's matching, something's matching. You laugh, but that's what you're going to do when you see it match and you start to like realize you're not doing something wrong. Right? When things start matching, you're like, oh, I can cancel things. I don't need the sign. Life is good. Yeah, exactly. All right. So, see ya. Wouldn't want to be ya. Oh, my gosh. You will throw parties in your head, trust me, when they start matching. So now they blatantly look the same, so I put LS equals RS. And Mrs. Lepp writes a sad face with tears. Because they don't look the same. Because my daughter would not say, those are the same. What would you have to do? Rewrite it. See how great that is? So fun. Yay. Then we're going to go to 8. Light bulb moment. All right. So here we are with this one. First thing we're going to do, rewrite it. So, LS, RS, sine 2x. Now, like I said, some people are going to try and write 2 sine x cos x. No. Our first step is to rewrite it. Everyone's first step should be correct because they involve you just rewriting the question. All right? Sine 2x minus cos x over 4 sine squared x minus 1. And then on this side we have sine squared x cos x plus cos cubed x over 2 sine x plus 1. So we could work with either side because there's no cos 2x's. If there's a cos 2x, I will always work with the other side, try and get it to be some simplified version so I can make some educated guesses with my cos 2x. Okay? I'm going to work with the right side because I immediately know what I should do. What could you do to the top? And we're stuck 99% of the time. What is it? Yeah, factor out a cos, a GCF. We can take a cos out. When you're stuck in proofs, I'm not joking. 99% of the time it's GCF or factoring that you're just not spotting. So then we're left with sine squared x plus cos squared x, which is something you will learn to really think is amazing. Because what is sine squared x plus cos squared x on your formula sheet? It is 1. That whole thing becomes a 1 over 2 sine x plus 1. So we get cos x over 2 sine x plus 1. Now we try and make that left-hand side match it. So sine 2x, what can we rewrite that as?
2 sine x cos x.
Yep. 2 sine x cos x. And the bottom often does not get spotted. What is the bottom? It's a difference of squares. So if off to the side, I'm just going to show you, if instead of a sine, if I had 4m squared minus 1, that would break down into the square root of 4m is 2m, so that goes to the front. The square root of 1 is 1, so that goes to the back, and then we have the opposite signs. So this would actually work out to 2 sine x plus 1, 2 sine x minus 1. Now we're starting to see some things here. I see that the 2 sine x plus 1's match in the denominator. Do you see that? So I know that the 2 sine x minus 1 needs to get out of my life. Is there anything I could do to the top? Take out a cosine. And then we're left with 2 sine x minus 1. TSN turning point. When you can spot that you are probably going to get this right, that is your TSN turning point. That is when you're like, I'm doing good. You go from like, to like, yeah. He's canceling. Then I say they match. No, I do not. I have to rewrite it so that the images look the exact same. So my 9-year-old can say, those are the same. And then you go LS equals RS. Yeah. Number 9, try it out. It's not a hard one. Okay, the left-hand side, what could I do? Oh, the right one? Yeah, I can do that as 1 over cos x. What can I do the left one? Take out a cos, yeah. GCF out of cos. When I take a cos out of cos, what's left? 1. Now you have to spot something here. What is tan? People who do Breland proofs know what's on their formula sheet. What is 1 plus tan squared equal to? Secant squared x. What can I change secant squared x to? 1 over cos squared x. Because remember secant squared x is just secant x, right? So if you don't know how to write, you can write it as secant x, and I have 1 over cos x and 1 over cos x. It would be the same thing. Or I can write it as 1 over cos squared x. And then those cancel. And they match. Ten is a very fast proof, actually, if you spot something. So the first thing we're going to do, LSRS. We have sine squared x minus cos squared x over sine x plus cos x. And here I have sine x minus cos x. Sine squared x plus cos squared x is 1. True statement. Sine squared x minus cos squared x is not 1. But what is it? You have 2 squareds with a minus sign in between. What can you do when you have 2 squareds with a minus sign in between? Difference of squares. 2 squared things with a minus sign in between is a difference of squares. So if I can do this offside, sine squared x minus cos squared x, and I replace them, m squared minus n squared, I would get m at the front of each bracket, and at the back, plus minus. Right? Just showing you that you can literally do that, right? So instead of doing the work off to the side with a difference of squares, what can you do? You put whatever the square root of the first is in the front. So what's the square root of sine squared? Sine x. What's the square root of cos squared? Cos x. Plus minus.
divide them like right off the bat though?
No.
What?
Like divide that in and get it, because that is illegal math in all states, territories, provinces. Mars, Venus, Jupiter, planets that have not been decided. The aliens would agree with me. You cannot do that,
Why not?
because that's not real math.
Sine squared divided by 20. You can't just cancel one off.
No, because this is one full term, and this is one full term, because a whole term is connected by plus or minus signs. So like when you have a plus or minus sign, so for example, in rationals, if I had x squared minus 1 on the top, and then I had x plus 1 on the bottom, I cannot cancel. I can only take an x plus 1 out for an x plus 1. I can only take an x squared minus 1 out for an x squared minus 1. So I actually have to turn that to x plus 1, x minus 1. And now the images match. And then I'm left with an x minus 1. So that's why when I check your proofs, it takes me a lot longer to do it, because I will check and see that your left side equals your right side, but then I have to check backwards to see if you broke math. Like if math was not done correctly. Because sometimes you will get it to work with your broken math, but it's not actually real. Okay? Does that make sense, though, how you can't cancel it off? It's a good question, Ryder, because I'm pretty sure everyone else probably would have done it the same way. Right? So you can't do that, because whenever you have something that's attached with a plus or minus sign in a bracket, it has to match exactly the same thing up top in order to cancel them off. Monomials, so example, if I had like 2xy z over xy, then I could cross an x and an x and a y and a y off, because there's no plus or minus sign for monomials. Monomials can cancel anything for anything. Binomials or trinomials have to match, like the image has to match in order to cancel them off. And I have to go one more step, sine x minus cos x, and so I get ls equals rs. Now we're flipping over. Yeah. Yeah. Okay. ls, rs. Rewrite. Stop yourself from immediately seeing that I can take a sine x out and writing it that way. You have to stop yourself. You have to rewrite the whole thing. That is your very first step. It has to be. And once you start solving these, you'll want to immediately try and take a sine x out in your very first step. But you cannot do that. You have to rewrite it. You have to rewrite it. You have to rewrite it. On the left side, I can take a sine x out. If you're trying to solve it yourself, go ahead. I take a sine x out, I'm left with cos x minus 1. What is the denominator? There's so many things we could do. We could go cos x plus 1, cos x minus 1. Right? We could go a sine squared of some sort, but you have to watch yourself. So if we have sine squared x plus cos squared x equals 1, if I want to get it in that form, this here cos squared x minus 1, I would move the 1 over here. So I would get cos squared x minus 1. But then what would it equal? Negative sine squared x. So you have to watch yourself. That you're actually using the form in the format. Like I would have to subtract sine squared x over. To get that. So I can replace this with negative sine squared x. That is a true statement. Can I cancel anything off? Remember, if a sine squared, if you're not sure if you can cancel, remember sine squared is just 2 of them. So I can write this as sine x cos x minus 1. And then this is just literally negative 1 sine x sine x. Can I cancel anything? Yeah, the sine x's, right? Bless you. So now I have cos x minus 1 over negative 1 times sine x. And what do I need? Remember, you can make either one be the same. You can make either one match. So if moving the negative 1 up is confusing to you, you can say, okay, well, I want that one to have a negative 1 in the bottom. So I'm going to multiply this by negative 1, and then this by negative 1. Do I have to always just work on this side? No, if you think it's easier, I just need a negative 1 down there, I'm going to put 1. But when I do the bottom, I have to do the top. Now I'm going to get negative 1 plus cos x over negative 1 sine x. Do the images match? They're very close. I just have to rearrange those, right? Positive cos, you remember when you rearrange, you take the sign that's in front of it with. So it's going to be positive cos x minus 1. Could I have just multiplied this side by negative 1 and negative 1, and then they would have matched too? Yeah, I probably would have done that. I probably would have just brought the negative 1 up, but that confuses people. So you can do whatever you want, remember? As long as your sides match, you're good. Remember, that's why it's harder for me to mark these, because I have to go back and check and see if what you did was legal. You guys try 12, and then I'll do the work on So I would like to draw your attention here for a second. If I want to say that these two match, they don't. I have to take a negative 1, because this is a positive 1 and a negative sine x, and this is a positive sine x and a negative 1. So I actually have to take a negative 1 out of this bracket. So then it turns into a negative 1 and a positive sine x, and then they can cancel. So then I'm left with negative 1 over, or negative 1 plus sine x over negative 3 sine x minus 1. Then they're very close but wrong signs, right? So I can choose whatever option I want to go. I can just add the negative 1 again to both. I can do what I did on the other one. Or I can take a negative 1 out of the bottom and they cancel and then they match. It doesn't matter. So I could go and multiply this by negative 1 like I did before, or I'm going to do the other way this time. I can take a negative 1 out of the bottom. and get 3 sine x plus 1. And then they cancel, and then they match. The questions I have for your homework, because we're going to go through them tomorrow at the very beginning of class, and it's Friday, so I want to just go through them quickly, are from the Trig 2 review. Remember the one that I normally want you to hand in, but I'm not making you hand it in? Because it is quite a difficult one. I want you to do these questions. So I want you to do numbers 5, 6, 7, 9, 11, 16, 17, and 21. These are due for tomorrow because we are going through them. If you don't attempt them, you won't have a clue if you could have got them or not. Because just copying down the work that I do is not, if you haven't tried it, is not helpful, because then you're just copying what I did and you never know if you can problem solve through it. Because proofs, for the most part, are puzzles. And it's not all just proof questions that I'm asking on there, but they're mostly proof questions. Myself,